Hello guys, today I'm gonna show you what is numbering system. Actually, numbering system is a basic computing like decimal, decimal, binary, hexadecimal, this kind of stuffs, megabytes, gigabits, this kind of stuffs. And without binary, 0 and 1, computer need to run this numbering system. And our life, human life, we're using this numbering system, that is decimal, 1 2 3 4 5 6 7 and 9 10 11 12, this kind of stuffs. And computer needs 0 1 1 0, this kind of stuffs for his life. And we need to understand what's computer, how computer works, and that's why we have to understand these binary systems. And also there is a lot of numbering system in our world, that is hexadecimal. Computer also understand hexadecimal. They convert binary to hexadecimal and then they do a lot of stuff like this way. Okay, if we continue at 0 1 2 3 4 5 6 7 8 9, and then the 1 will come at the first, and then again count from 0 1 2 3 4 like this stuff. Okay, let's check. Oh, it's a 10-digit number. We in our life we use 10-digit number, and binary system it's only 2-digit number, that is 0 and 1, nothing else. And in hexadecimal it's a 16-digit number, 1 2 3 4 5 6 7 and 9, and then it's A B C D E F, and then it counts from 0 again, and before that there is a 1. Okay, 1 0 1 2 1 3, like this way. Okay, let's check out. Like 1, all the digits already we have written, that's why we start with 1, and then again from 0 to 9, 0, then 1 1, then 1 2, then 1 3. We know already, we know about this stuff, 1 4, and so on, so on. Okay, in binary, if you see in binary, then what we found, yeah, then 0 1, we already complete these 2 digits. Then again it starts from 0, and before that there is a 1. Okay, then 1, before that there is a 1. Okay, then we already complete this cycle. Then we have to start with a new cycle, that is 1 1 1 0 and 0, and then 1 0 0 1 0 and 1. Okay, we complete this cycle. Then 1 1 0, and then 1 1 1. This is how we have to write the binaries, this way. It's similar to decimal also. And in hexadecimal we might, what will be the next step, you can say what will be the next step. Okay, let me give it some space. What will be our next step? Okay, we have to put the 0 here, starts again, so 0, and before the 0 we have to put the 1. Okay, and then we have to put 0 and then 1, and before the 1, that is 1, and then 2, 1. This is not 12 actually. This is hexadecimal format. So I'm writing here 3, 3 and 1 and so on. I hope you understand the numbering system, and the important things you have to know. The main fact why I'm creating this video is this one. This is a binary numbering systems values. These are the values 1 2 3 4 1 2 4 8 16 32. It says twice square, twice. This one into no, this is not like that. 1 apple and 1 apple equal to 2 apple. Okay, 2 apple, and 2 apple plus 2 apple equal to 4 apple. 4 apple equal to 8 apple. That means 2 square. Okay, not that 2 square, it's a twice, double. Okay, 8 double 4 16, 16 double 32. These are the things. This is how this number is going on, and it is a means of if the above line, in the above line, it is a binary number. It's in the box, it's the binary digits. Okay, if the first digit of a binary number, if it's found 1, then we think it's a 1. And if it's 0, then we'll found it's 0. If the second box, if we found that it is 1, then we'll think that this value is 2. To convert in decimal, I'm talking about converting in decimal. If this digit is 0, then we'll think that this value is 0. If it's 0, then we'll think about this digit is 0. Like in first, second, third, fourth, fifth. In the fifth box or fifth bit, the binary digit shows 1, then we'll think that the decimal should be equal to 16. In decimal, it equals 16. And if it's 0, then what we think in decimal? We'll think that it's also 0 digit in decimal. No value. 0 have no values in no numbering system. Every numbering system, 0 have a value equal to 0. Okay. Let's try the next slide. Binary to decimal. Okay, in practical. I have made this one. You'll get more clear in this example. What does this mean? This is a binary number. This is a binary expression. Can you convert it to a decimal? Okay. In this example, we'll clear how we understand the binary number to decimal. Okay. In the first bit or first box, there's a 1. What do we think? If there's a 1 in the first box, we'll understand it is 1. Okay, write 1. And in second box there is a 0. So if there is a second box, there is a 0. What we will understand? It's a 0. Okay, 0. That means we will understand it's a 0. And in third box or third bit, there is a 0 also, so no problem, it's a 0 undoubtedly. In the fourth bit, if it's 1, then what do you think? 1 2 first, second, third, fourth bit, there is a 1. What do we understand? It's a 8. In decimal, its value will be 8. And what if there is a fifth one in a fifth there is a 1 in a fifth bit or fifth box? You will understand it will value of 16. And in sixth bit there is 0. Wherever the 0 is, the value will be always 0. This is the sixth bit. 0 means 0. So you know, 0. I'm adding all these stuffs. Is 16 plus 8 equal to 24 plus 1 equal to 25. Of course it's in decimal. Okay. This is how we understand how to decimal to sorry. This is how we understand how to binary to decimal conversion, how we will treat a binary numbers. Actually, you think that there is no need to understand this kind of numbering system. Actually, you will be completely wrong if you don't understand this numbering system, because wherever you using computer, it will need it somehow, sometime, someday. Like how many gigabits, how many gigabytes have a disk capacity, this kind of stuff. Okay, I'll let you know more details in my next videos. If you like my videos, please comments, and if you want to know more, please comments or subscribe or like. Subscribe means this kind of video, you will get this kind of video whenever I upload this. I'm sorry for taking a long time. Thank you. See ya.